So hi everyone, my name's Kyle Knapp. I'm a software developer at Amazon Web Services, where I primarily focus on developing Python-based client-side tooling for AWS. So projects I work on include Database CLI, Database SDK for Python, also known as Boto 3, and Database Chalice, which is a Python serverless micro framework for AWS. And today I'm going into detail about some of the lesser-known code quality tools out there that can help you improve your code quality and your automation systems around code quality. So to give a little background on this talk, it was mainly motivated by a PyCon talk I gave earlier this year about automating code quality. If you've seen this talk, that's great. I'm going to be building off of it. In the case you haven't, that's no problem at all. I'm going to be recapping the bits that you need to follow along. So let's talk about what it means to automate code quality. And in the PyCon talk, I described the system we have in place for Chalice. Chalice is a Python serverless micro framework for AWS, and it works as so, where we have tools that we care about, such as Flake8, pylint, coverage, that we run on our code base to check for code standards, styling, and potential bugs. Everything, or the way that they're ran, are all organized in a make file, so that when a developer wants to run all the tools, they can run make plus the target, being PR check, to go ahead and run all the tools on the current code base. And if all the checks pass, they can go ahead and submit a pull request to GitHub. From there, GitHub will trigger builds by services such as Travis CI and CodeCov that will run the checks from the make file to get results on their end and report back to GitHub. And if all the checks pass, that means the pull request is in a good spot to review. And likewise, if the checks fail, that means we probably shouldn't merge this pull request. We probably should get the checks passing before moving on. So let's go ahead and talk about the benefits to this. In the PyCon talk, I outlined 3 big benefits. First, it enforces the quality checks have to pass in order to merge the code. There's no exceptions to that rule. It's going to make your code reviews a lot more efficient. So contributors are going to be getting feedback a lot sooner. And also, it's going to be a lot easier for the reviewer because there's a lot less things they have to worry about. And finally, it's going to help protect developers from mistakes. No matter how well you know the quality checks, everyone's human. The machine's going to be a safety net so that your mistakes don't get leaked into the code base. And when people think about code quality tools, they think of the mainstream ones most likely, such as Flake8, pylint, coverage. I recommend using them all. I went into depth about these in my PyCon talk. However, there's also lesser known tools such as docstyle, doc8, and MyPI. And these tools are important as well because they cover some gaps that some of the mainstream tools don't really cover. And by covering some of these code quality gaps, it's going to increase the benefits from having an automation system. So for the rest of the talk, I want to focus on some of these lesser known tools so you can improve your code coverage and take your automation systems to the next level. So the code quality tools I'm going to be covering today include MyPI, plugins for pylint, and some tools around quality of documentation. Starting with MyPI. MyPI is a static type checker for Python. It's going to be using annotations from PEP 484 and analyze your source code to see if there's any issues with your type. So to give an example of how MyPI works, here is a hello.py file with a function format hello. If you notice at the top, there's annotations in its signature. So name is a string, is morning is a Boolean, it returns a string. To get started using MyPI, all I have to do is pip install it. Note that MyPI is only supported on Python 3.4 and up. And run MyPI on the file. Running MyPI, you won't get any errors because there's no issues of type here. So let's go ahead and put something in the code that will cause an issue of type. Specifically, we're calling format hello with the value none. Format hello expects a string, so MyPI is going to throw an error when you run it. And this example really highlights the usefulness of MyPI because it's going to give you a whole level of coverage related to proper uses of types. So if you're making sure you're passing the right types into function calls. And on a similar note, it's also going to make sure your return value types are correct as well. So in this example here, I have default hello, but never actually return it. And MyPI is going to complain about that. Because if you don't have a return statement, say if is morning is false, it's going to return none. And that's likely a bug in your code. And in which our case it is, because we expect a string type of a return type of a string. So let's talk about how you integrate MyPI with your project. The first thing you're going to want to do is configure MyPI. So to do that, you need a mypi.ini file. This is the main file used for configuration with the MyPI sections for the global configuration for that repository. One configuration option I recommend having is the one on use configs and setting that to true. And what that will do is make sure you don't have any misspelled configuration options or options that are not supported by MyPI. So you can see here, if you're on MyPI, it's going to throw an error, or warning rather. Another thing you'll run into when running MyPI is it's only going to be following functions that are annotated. So if we run MyPI on this updated file now, we won't get any errors out of it. And in general, you want to make sure you're annotating all your functions and methods because that's going to give you greater type safety in the end. So to enforce that all your functions and methods are annotated, you can set the disallow untyped defs to true here. And what will happen now is when you run MyPI, it's going to throw an error saying this untyped function has no annotations. So another thing you may run into when running MyPI is you may use an external library that has no annotations. So for example here, we're using the formatter class. It has no annotations. And you run MyPI, it's going to complain that it can't find the module. And that's because MyPI tries to follow imports to determine annotations. And if the library doesn't have any annotations, it can't follow it and therefore throw an error. For those cases, you really don't have much options given that you don't really have control over this third-party library, in which case the best way to go around it is to create a new section specifically for that library. You can do that by specifying my plus the name of it. Note the dot asterisk right there means that any modules, apply this to any modules of that library as well. And you can set a configuration option to ignore missing imports as true. So what that will do is if MyPI can't follow the imports, it won't error out on you. In the case where you want type safety for Python 2, you can do that. You just have to make a little bit of modifications. Specifically, you can't use the signature type of annotations. You have to use a comment-based annotation supported by PEP 484 because this annotation signature is only supported on Python 3.5 and higher. Furthermore, you can set the Python version to 2.7 in your mypi.ini file. And then from there, MyPI will look at the comments, the annotations in your comments. And another important note is that even though you're trying to run it for Python 2, you still need to run it in a Python 3 environment because MyPI only runs on Python 3.4 and higher. So let's go ahead and recap MyPI. So MyPI is useful because it's going to help you better document your code and catch bugs related to types. If you want to configure and tune MyPI, you should use a mypi.ini file and tune it to whatever standards you want. And also, as a reminder, it's Python 3 only, but it does support comment-based annotations for Python 2 if you want type safety there. So moving on, let's go ahead and talk about pylint plugins. So if you're familiar with pylint, it's a static code analysis tool that's going to be looking for things such as following code standards, so making sure you're following PEP 8. Warn you on style issues, so if you named a variable or class weird. Or find potential bugs, say you have an unused import, unreferenced variable, or even default mutable arguments in the signature of a function. And pylint in general is going to be very opinionated, very chatty when you run it. And it doesn't catch everything. There might be some standards that you care about, but pylint doesn't catch. In which case, pylint has a plugin system where you can write your own checkers to use when running pylint. And one standard that I want to go over that we used today with Chalice is setting a standard of making sure when you instantiate a mock, always use a spec argument. And to show an example of this, take this deploy.py file on the left. And we have a client class and a deploy function. The deploy function will use the client to go ahead and deploy an app. If we were to go ahead and test this now, it would look something like this. In order to test the deploy function, we would create a client via mock, set a return value, call the deploy function with that mock, and then assert that the client methods were called correctly. Running PyTest on it now, you'll notice that the tests pass. However, you can also just call some non-existent method, say we were factoring and forgot to remove that line, and the tests are still going to pass because we're using a mock here. Pretty much you can call anything you want a mock, and it's just going to work without issues. Ideally, we don't want this, right? If we try to call this for real with an actual client, this is going to throw an attribute error, and we want it to be more realistic. And in order to better test that, we like to use the spec argument. So specifically, what it will do is that any attribute provided outside of the class provided will throw an attribute error for that mock if it's tried to be accessed. So now, if we run PyTest on this, we're going to get a failure, and specifically, it's going to be the attribute error that we wanted. So the question now is, how do we make sure that all of our mocks use specs? Running pylint on the test deploy right now is going to give us a 10 out of 10. Right now, it doesn't look to make sure that our mocks have specs. So in order to support that standard that we have, we created our own pylint plugin. Specifically, we can run pylint now with the load plugins parameter. And what that will do is throw an error now when it notices there's no spec. And now let's go in to talk about how we implement such a linter. So looking at this value, this is the value provided to load plugins. It's simply the module name for our pylint plugin. This is coming straight from the Chalice repository. So you can see that the first thing you need to define is a register function. When pylint loads your plugin, it's going to be calling this register function to start. And then from there, you can go ahead and register a checker that you want. So we're registering our mocks use spec arg checker here. And now going into the implementation of how mocks use spec argument works, you look at it, it's not very many lines of code. It looks not too bad to write. So let me go ahead and walk through it. So to start, you need to define some class properties related to configuration, errors, messages, and also define the dunder implements property. And the dunder implements is going to tell pylint how to run this checker exactly. There's a few different ways you can run a pylint checker. By specifying I_asteroid checker, what it's telling pylint to do is treat this as an abstract syntax tree walker, or AST for short. AST is a hierarchical representation of the syntactic structure of code. So the idea is that pylint will take a library called asteroid and give a higher level representation of the source code that will let you walk and visit the specific components or nodes that you may care about. In order to visit these components, you need to implement visit methods. So here we're implementing a visit call. So this method will get called whenever a call is encountered in our source code, such as here on the right. Likewise, you can visit a whole different range of nodes based off what the asteroid class name is. So for example, I could have visited the import statements. I could have visited function definitions. I could have also visited assignment of names. There's a lot of possibilities out there. So now going into the actual visit call method, what we're going to do first is call node.infer. And what that's going to do is give you a bunch of different values, the potential values that could be. And based off that, we're going to be looking at what the type of that inferred value is. And if it's a mock, we're going to go ahead and look at we're going to introspect the node specifically for the keyword arguments. So you can see if there's no keyword arguments provided, we're going to add a message. If there is, or if spec's missing from the keyword arguments, we'll go ahead and add a message. And by adding that message, it's going to propagate up to pylint when you run it. And that's all you need to do. It's pretty straightforward. Pylint gives you a lot of things to work with in order to get working with it. So wrapping up, I encourage everyone to write plugins they care about. And for additional pylint examples, follow that link. These are all to the built-in pylint checkers, so they all follow the plugin format, so you can use that for reference. Moving on to documentation. So there's various different tools related to quality of documentation. It's often overlooked, which is unfortunate because documentation is the introductory way for someone to learn a code base. So the three tools I'm going to talk about are PyDocstyle, Doc8, and Sphinx. Starting with PyDocstyle. PyDocstyle is a docstring checker, and it's going to check your docstrings based on PEP 257. And let's see what it's going to find. So for example, here we have this doc.py file. To start using PyDocstyle, you can pip install it. Then you can run PyDocstyle on that file. And looking at the errors that it generates, it's going to find issues with your formatting. So for example, using single quotes instead of double quotes and not keeping your docstring one-liners to one line. It'll also find whenever you don't have documentation for your public interfaces. In general, you want to make sure you document everything, all your public interfaces for your users. It also skip over anything that's not public, hence if it begins with an underscore. And also, it's going to be looking into the contents of your docstring. For example, here we don't use the imperative mood or end with a period. So in the end, PyDocstyle is going to give you a lot more consistent and code standard and make your docstrings follow code standards. So moving on, let's talk about Doc8. So Doc8 is a restructured text checker. So as a reason why you would care about it, let's take this bad restructured text. And if you try to use Sphinx to render some HTML out of it, it gets something like this. You don't want your users coming to this page, just doesn't look impressive. You can see there's a bad link, the print is not in the code block. So what doc8 is going to give you is a real quick check to make sure your restructured text is well formatted. And that way you get well formatted docs in the end. So to use doc8, you can just pip install it and then run it on the restructured text file. So for example, now you'll see all the errors related to this, where the underline is too short, the print statement's not in the code block, and the link is bad. So that was it for doc8. The final one I want to talk about is Sphinx. With Sphinx, you're probably familiar with Sphinx if you've built Python documentation before. And the idea is if you have a Sphinx project or some restructured text, you can first install Sphinx and then generate a bunch of different outputs, whether it's HTML, JSON, LaTeX, or eReader. And all these makes are coming from the make file in the Sphinx Quick Start when you create a Sphinx project. But you also have different builders available to you to validate your documentation. For example, you can do a make link. You can use the link check builder to make sure that you don't have any broken links in your code, links in your documentation. So for example here, this no exists. That's not a repository in the AWS GitHub org, so I'll flag that for you as well. One thing you may notice at the bottom here, I have some invalid JSON. I'm not supposed to end it with a comma. So let's talk about how we can go in ahead and validate it, because Sphinx doesn't have a built-in checker for that. So let's make our own, because Sphinx allows you to plug in similar to pylint in order to make your own quality checks. So the builder I'm going to make is called JSON check, and the idea is that when you run it, it's going to print out anytime it runs into invalid JSON, such as below here. And in order to implement it, it's very straightforward. It's similar to the pylint plugins, where you have a single file, JSON check. You have to first define a setup function that Sphinx is going to load when it loads in your extension. And from there, you can go ahead and add your builder. When implementing your builder class, you have to specify a name for the builder. And also you have to implement some methods. For most of these, you can just call pass or return. They're not really relevant for validation. The one function you will have to implement is the write doc method. And if the write doc method, it gets called anytime you're trying to write output for a single file. So it provides you the file name and the source doc tree representing the source. A doc tree is similar to pylint in terms of using Asteroid to make an ASC representation. But what Sphinx is doing instead is using docutils to import the source code to make a higher level representation of the code so you can walk it yourself and visit the specific components or nodes that you care about. So in order to do that, to start the walking process, you need to call a traverse method. And what that will allow you to do is go ahead and walk through each of these nodes one by one and introspect it based off what you may care about. So for us, the one thing that we care about are literal blocks. Note that code blocks are literal blocks. And more specifically, we can see if it's a JSON code block by looking at the language attribute. And once we know we're at a JSON code block, we can then try to validate the content of the node with this is valid JSON check. Specifically, we're using the as text to get the actual value of it. And if it's not valid JSON, we'll go ahead and set the return code to 1 and print out an error. So when Sphinx exits it, it'll be a build error in the end. That's all you need for the build logic. Similar to pylint, it's pretty straightforward to implement. The only thing left you need to do is add in your conf.py file. This is how you configure your Sphinx project. You have to insert the JSON check into your syspath if it's not a Python package, and also add it to the extensions. So from there, you're good to go. It's pretty straightforward. There's not much you have to do to get this working. And from that, I'll do a quick recap. So first I'll talk about docstyle. It's a docstring checker. There's doc8 to make sure you're going to make sure you have valid restructured text. And there's Sphinx, which you can use builders to further validate your docs. So to conclude, tools I covered included MyPI. It's a static type checker for Python. There's pylint plugins to write your own checkers that you may want. And I talked about various different doc tools. And finally, I really encourage everyone to explore the different ways they can automate away their code quality gaps. If you see an issue in your code base, try to find a tool or write a plugin that's going to catch these issues. Because in the end, it's going to help your code base have a higher code quality. It's going to make your software development practices safer and more efficient. And before I let you all leave, here's some links I recommend checking out. And I really appreciate you all listening in on my talk and hope you got a lot out of it. Thank you. Oh. Yeah.
How do you compare plugins for pylint and Flick 8?
So the one thing with Flick 8 is you do need the setup. So that the nice part about pylint, you could just have a single file and just kind of just call it directly. But you get a lot of the same functionality with Flick 8 if you want to use that as well. But yeah, that's definitely an option. Yeah.
If you have multiple repositories and you'd like to enforce the same rules across them, how do you share those configurations? Do you have it duplicated in each code base?
So right now we kind of have it duplicated, which is unfortunate, but I think ideally we wouldn't want to somehow even make like its own Python package and our own repository so we can actually share it and like clone it. But I think that would be like the next step in order to enforce like a specific standard each one. But that's...
How would you handle like updates to it? Like you said, it's in the make target. So if you have it as another repository, when you go to make to run all your checks, it would then need to pull it as well.
Yeah, I mean, what I would do is I would have a dependency, or when I run it, I would try to clone the repository or something at least, and then from there you can get the most updated make file and then run it from there. The one thing that's interesting is that if you do have your own repository and one code base is currently failing those checks and you pull it in, that means that it's going to start failing all your builds, which is not what you want. So that's a little bit tricky there. You'd have to somehow pin it.
Do you know if any of these tools support a central configuration location?
Yeah, some of them do. I believe MyPI does. I want to say pylint does too. So you can just have it on your home directory and it pull that in. I'm not sure about all the other ones though.
You could also look into sublines. Sublines is like any sort of repository. You can, if you have a sublevel to mono-layer update stuff, you'll always look to locations.
Cool. All right, yeah. If anyone has any more questions, I'll be outside to talk and stuff. Just let the next speaker come up.